This is part 2 of the lesson for determining the radius of the Earth if the Earth was pure nuclear material. You can see that the density of pure nuclear material is extraordinarily high, 2.3 times 10 to the 17th kilograms per cubic meter. The density of the Earth is 5.51 grams per cubic centimeter, which is the same as 5.51 times 10 to the third kilograms per cubic meter. So we have very, very dense material, and we know that the Earth is very large. What we're going to do first is we're going to calculate the radius of the Earth, knowing that the density of the Earth is 5.51 grams per cubic centimeter, and knowing that the mass of the Earth is very large, and we'll actually look up that value. And this is the value for the mass of the Earth. It's 5.972 times 10 to the 24th kilograms. Now, we have the mass and the density, and we're going to calculate the volume. Volume equals mass over density. Now, it also equals mass times the reciprocal of density. So there it is. That's the mass times the reciprocal of density. Then I'm going to multiply it, and so I cancel out the masses, so I'm left with just volume. So there is the volume of the Earth, 1.08 times 10 to the 21st cubic meters. That's a lot. That's like a trillion times another 1,000. That's a lot. There's the general volume of a sphere, and if we solve for cubic radius, that's the expression, then we're going to take the cube root to solve for just the radius, and then we're going to plug in. And we know the cubic radius is going to equal 3 times the volume divided by 4 pi. Then we'll take the cubic root and solve for the radius. And the radius is going to equal, relative to the normal Earth, the big Earth that we know, very large, it'll be 6.37 times 10 to the 6th meters, which for any Americans looking at this really doesn't mean much to you. We know that 6.37 times 10 to the 6th meters is the same as about 4,000 miles. I probably meant to say 6.37 times 10 to the third kilometers, but either way. So now, we have the density of nuclear material, we have the density of the Earth as we know it, we have the mass of the Earth, we have the volume of the Earth, again very large, 10 to the 21st, that's 1.08 and 19 zeros. So it's 1.08 times 10 to the 21st cubic meters. And now we also know the radius of the Earth. We know it in both metric and in British units or American units. And that's going to be 6.4 times 10 to the third kilometers. Wait for it. So about 6,000 kilometers, 6,400 kilometers. Or, in terms of English units, it will be 4,000 miles in terms of English units. So, now what we want to do is we want to solve for the radius of the Earth if it were pure nuclear material. What is the radius of a mass of pure nuclear material whose mass is equal to that of the Earth? So it would be, very simply, the mass of the Earth, as we know it, divided by the density of the nucleus, or the density of nuclear material. So now, if we understand that the mass of the Earth divided by the density of nuclear material is actually the mass of the Earth times the reciprocal of the density, and we plug in, we see that the kilograms cancel, and you're left with a volume in cubic meters. Now, remember the volume had an exponent of 10 to the 21st, and this is going to be 10 to the 7th. So it's considerably less volume. And also remember, it's going to be a cube root of the volume. It's not linear. So it's going to be a much smaller, disproportionately smaller radius as a result. We know that the volume of a sphere is 4/3 pi r cubed, and we know that the volume is going to be put in, and we're going to rearrange the equation to solve for r cubed, then take the cube root of each side, and we get the cube root of 3 times the volume divided by 4 pi. Now we know that we just bring that forward, and we do the calculation, and we get 184 meters. Now, that is extremely significant because it was 4,000 miles or 6,400 kilometers. Now it's 184 meters. So let's look at what that means. If the Earth, now if anybody's ever been on a plane flight to Europe or to America from Bangladesh or vice versa, you know that the radius of the Earth is not 184 meters. An American football field is 100 yards, which is smaller than 100 meters. This is just 2 soccer fields. I have some students in my class right now. What is the distance from goal to goal on a football field? European football, soccer, about 100 meters?
I guess it's a bit more.
A bit more than 100 meters? Okay. So 2 of them, 2 football fields would be greater than 184 meters.
Yeah.
So can you imagine the Earth, if the radius of the Earth was only 184 meters instead of 4,000 miles or in excess of 6,000 kilometers, that would be a very small Earth. So let's summarize. If the Earth were pure nuclear material, if I had a sphere with the weight of the Earth that was pure nuclear material, the radius of that sphere would be 184 meters. That's how incredibly dense nuclear material is. That, ladies and gentlemen, is what a black hole is. A black hole is pure nuclear material without the electron. So if I have a book, here's a book, right? Here's a textbook, right? Here's a textbook. I hit it on my head. If this textbook were pure nuclear material, it would probably be microscopic. I probably couldn't even see it. It would be that small. You get it? Isn't that amazing? What is a textbook? A textbook is mostly electrons. So I'm hitting my head with electrons. Yes, you get a concussion. I just hit the computer with the textbook. That was that bang. Get it? All right. Very nice. They're taking quizzes, so continue with your quizzes. My 7th grade. Wonderful children. Have a good day. And goodbye. You're welcome.